Well, good morning, good afternoon, good evening, wherever you are in the world this today. We are Logic and Reason, and I am one of your hosts, Logical Troglodyte, along with my co-host, Jeff from Steaming Cup of Reason. We have a great show lined up for you, but before we get into that, let's go around the room and introduce everybody. Jeff? Jeff, are you here? Did we lose our Jeff?
He's
Well,
paper towel there.
Hello everyone.
There he is.
Steaming Cup of Reason here. Sorry I missed out on that. The old mute button attack happened. Good to be here with you, Logical. And hello everyone for another great episode. We're going to be talking about some really interesting stuff today. And I'd like to take this opportunity to introduce a returning guest. We are very happy and very proud to have him with us once again, Professor Philip Bell. Professor?
Yes, good evening. It's good evening over here anyway, around about just past 10 p.m.
Yeah, good morning. Well, good evening to you, and good morning to everybody in North America. And also returning with us is Mike the engineer, also known as Mike Bertelson. Mike, say hi to everybody.
Hello, everybody. Looking forward to talking about the moon.
All right. And unfortunately, our chief mod, Amy, has not been able to join us this morning. So I will ask the mods in the live chat to keep everything on an even keel up and up, just in case we have any conspiracy theorist commandos decide to join us this morning. They are welcome, provided that they are not saying things that are socially inappropriate. You guys know the drill. Please do not time them out unless they are saying things that are, racist, homophobic, and all that kind of weird stuff. If they are spouting whatever they're spouting, that's fine. If their comments are on topic, we will be happy to address them. So with that, we'll get into the show. Today we are examining the conspiracy theorist claims that the moon landing is fake. And also we have later on in the show, we have a little bit of an extra treat. Professor Phil Bell has been challenged by a conspiracy theorist to explain tides as it relates to electromagnetism. So later in the show, we'll also be discussing other moon-related conspiracies as we beat the moon landing is fake horse to death. So one of the things that conspiracy theories like to say when they're examining the Apollo moon landing footage is that that's just slow motion that they're doing, slowing the camera speed down to give the illusion of lower gravity. And we all have a lot to say about that, but I think I'll open the floor to the professor and let him get this ball rolling.
Okay, well, just addressing that particular thing, having a look at some of that footage, they must think these astronauts have extraordinary strength at jumping. They ought to join the Olympic team at how good they can get off the ground, and for a long time as well. So that they haven't even probably considered that, how high up they go.
Yeah, and what I think the professor is referring to, and correct me if I'm wrong, sir, is that when the astronauts jump, they are barely bending their knees, yet they are jumping several feet high.
It's something a bit like my cat does that, actually. Yeah. Seems to be able to do that.
And those suits they're wearing aren't necessarily light either.
No, they aren't. They're quite heavy. Those that would be at least 30 to 40, maybe 50 kilograms, so at least.
Not to mention they couldn't jump that high even without having the suits on. I mean, it's just ridiculous. Additionally,
that's right.
It's one of those claims that is just that. It's a claim. Nobody's ever tried to replicate such a thing. It is one among many straw man arguments where, you know, they say this and then you have to then disprove this, but they have not
Yeah.
shown a single shred of evidence to support such an assertion anyway.
Mm-hmm.
Well,
And
the thing
with-
about it is they make false premises, you know, that's to start with.
Right.
And with any conspiracy claim, assertions provided without evidence can be disregarded. Another thing they like to talk about is when the Apollo 11 astronauts planted the flag on the moon, that all of a sudden the flag was waving. You know, they forgot to turn the fans off in the studio. Have they never heard of a thing called kinetic energy?
Yes,
You know,
true.
the movement of the astronaut's hand.
Actually,
And,
one of the things is the flag. Once they put it in, it's a flexible steel flagpole and a rod that holds the flag straight out. And if it starts moving, there's actually no atmosphere, so there's much less friction for it to slow down. It'll actually go on for a long time. Actually, the Mythbusters also did an excellent episode in a vacuum chamber to show that that's just complete and total nonsense as far as as evidence that the landings never happened. They proved that it can happen exactly as you see it on the old films.
Yeah,
Newton's first law of motion right there.
Yep.
absolutely. I mean, they jab that pole into the ground or into the surface. Of course, it's going to vibrate, causing the flag to move. I mean, that's common sense.
Well, not only did they actually jab it into the ground, but they twisted it.
Yes.
Of course, it was going to move.
Yeah. That all causes vibration within the pole
Yep.
and the arm holding the flag out. So, of course, it's going to wave a little until they
Yep.
stabilize.
Yeah.
And our producer, Teddy Bogle, which I forgot to introduce in our opening, and I'm really sorry about that, Teddy, is doing double duty today. He's controlling all the whistles and bells to make sure our stream stays live and without any interruptions. And he's also going to be watching the live chat for us. And he just alerted me that he has a few chats that he'd like to, messages that he'd like to read out for us. Teddy?
Hi, Logical. Thanks, mate. Thanks, mate. No worries. Yeah, just a couple of quick ones straight off the bat from our friend Digital Demonic Davros. He's saying that he has a hypothesis that the moon landings were engineered, but the wires and shadows and stuff, he's got no evidence for them.
Okay.
But as I say, the chat themselves, they've been pretty good so far. Not too many questions or comments so far. So I'd just like to remind them, if they do have anything, please at Logic and Reason, and we'll get your comments and questions read out.
Thank you, Teddy. And before we move on to another aspect of the moon landings that the conspiracy theories like to spout, does anybody here on the panel have anything more to say about the ones we've been examining so far?
No, I think they're pretty straightforward.
Yeah, it all pretty much is. Okay, and you know what? I did see a video in the last week or so that I thought was rather interesting. A conspiracy theorist was examining he was playing around with the sound from the astronaut's microphone, and I forget which moon landing that he was reviewing, but he was apparently hearing in the microphone the scraping of the astronauts' boots in the regolith of the moon and whatnot, and he was trying to say that it was obviously in a studio, because how would the microphone be picking up any of those sounds without an atmosphere? I have my ideas about it, but I want to turn to our two scientists on the panel and see what they have to say before I weigh in.
It would be hardly surprising if it did make a sound, because how could the boots not transfer some of the vibrations to the suit, and the suit therefore transfer some of the vibrations to the microphone? Why would that be a problem?
Yeah, I'm not sure.
the microphone is actually fixed to the suit itself, so it's going to pick it all up. Not to mention
Well,
the astronaut does move his head around inside his helmet. I mean, he can turn, he can. You're going to hear all that, just like, you know, if I were to touch my microphone and or touch the
remember, he's
frame
got an
outside.
atmosphere in his suit.
Yeah, so you know, all that
Yeah, I was
sound will
about to say that.
transfer.
Yeah.
It's an interesting idea, but I can't see. There's so many other more reasonable explanations for those sounds than uh, we're in a studio. I mean,
Right.
Yeah.
that's a big leap from a sound to
Yeah.
caused by a studio.
Right. Now, one of the other
That's
things
easy
in
to
that
argue that one.
particular one of the other things in that particular video that he was complaining about is the astronaut was using a hammer to hammer in the core bit to take a little sample of the moon core, right? And you could kind of hear the tink of the hammer in his microphone. Now, from where I'm standing, what I understand of sound waves and microphones, that it's not unreasonable to think that the sound wave is traveling from the hammer down through the pole, through the through the regolith and the crust of the moon, and up through the soles of the feet and into the atmosphere of the spacesuit, which then transfers the vibrations to a little bit of a sound noise within the microphone. Professor, do you think I'm off base in how I'm describing this?
I probably think it sounds like a good hypothesis, but I think that probably knowing a little bit about what I know about the actual moon dust, as it's the colloquial word for it, I think that probably wouldn't be so much. I think probably what's happening is that he's actually moving himself in the spacesuit, and there's all sorts of different apparatus attached to that spacesuit that could easily make it clink. It wouldn't be the hammer.
Mike, what do you think?
Well, I kind of agree with Professor Bell. It may be possible that some vibrations can be transferred through the hammer into the suit. I mean,
Yeah.
but I don't know how much you would be able to pick up on the mic. It may or may not be. I know that in engineering, a lot of times, if we're trying to test like the natural frequency of a given system, there are hammers that we can use to tap on them that actually have sensors in them to measure the vibrational frequencies that come from such a strike. So that it does transfer in some cases. So I could see that there could be some transfer from the strike. There could be some due to the motion of the astronaut itself. So there's multiple sources that could give you what seems to be an overt clink.
Yeah, it emanates from the suit. But one thing you can say for certain, you can't. Nobody can. Certainly, they can't say emphatically that a hammer caused it. They can speculate, but that's about as much as they can do.
Plus, it seems kind of out there that the guys who spend, if they were to fake all of this, why would they make such obvious mistakes? I mean, that doesn't really make any sense in a conspiracy sort of way, because they fake. If you believe them, they faked not only one, but all of the trips to the moon, and you think they would have that figured out.
And then it could be a fault in the audio recording.
Yep.
It would be really unreasonable to make the assumption that some of the smartest men and women on the face of the planet of those days would make such gross errors.
Yeah, exactly.
Yeah, from a conspiracy standpoint, a country like the Soviet Union at the time would have loved nothing more than to prove the United States faked it. And if it were that easy to prove, they'd have done it.
And they have their lab is just as good as the FBI's lab, so they could have.
Yep.
Yeah, they would have been all over it in no time.
Yeah, Janie in the live chat was talking about that before the show started. And that's one thing that conspiracy theories don't really address is the other evidences for the reality of the moon landings, such as ham radio operators triangulating where the signals were coming from, the political aspects of the space race between America and Russia, and how Russia would have really jumped all over us had we even tried to fake one minor aspect of what we were doing. So yeah, let's go ahead and explore those ideas.
If I can start with this, there were 19 launches of Gemini, and 10 of them had crews, and each crew was two astronauts per crew. So there was 19 launches between 1962 and 1966. So how many times do they have to fake this thing? I mean, even let's say, for instance, the two types of people who say the moon landings are fake. There's the people who don't claim that the Earth is flat, and then there's the type who claim the Earth is flat. Well, I'm talking to the flat Earth people. The Gemini program had 19 launches, and 10 of them had crews. So 20 people went up there. How many times would they have to risk faking it? And why would they need to do it 19 times? And then Mercury mission, 6 crewed missions in the Mercury between 1961 and 1963. This is long before they even were ready to do anything with Apollo, and there were 17 of them.
It just makes no sense.
How can that make any sense?
So between Mercury and Gemini, that's 24 men going into space altogether, 20 some odd launches, and each one of those was for a specific purpose, a learning curve, so to speak. How does this work in space? How does that work in space? They were testing individual aspects before they risked lives going all the way to the moon. It's just unreal to think that they would have to fake, all these different programs from Mercury to Gemini to Apollo, and keep that going, and all the thousands of people who would have to be in on the conspiracy theory to keep it going, and not one deathbed confession. It's like, come on, to me, it's just completely unreasonable.
It's totally unreasonable, and I've got a particular interest in it because, as you know, we're working the Indian Space Research Organization is working on sending a human to the moon. I mean, the date's probably going to be pushed back now, but that was going to be 2022, I believe, 2020 or 2022, going to have humans land on the moon. So, I mean, obviously there's all of this to consider, but one of the biggest considerations in all of this is, can we get the humans back? And this is the big issue. Can we get them safely on the ground? And then can we get them back? And until that is an absolute certainty, like when I say certainty, I mean a probability of 99.995, they're not going to put a human on the moon. It just, there's no way known the moon programs would survive a human dying on the moon. That just would be unthinkable.
Yeah, and with that, Teddy's got some relevant comments to this part of our conversation. Teddy, you want to read those out for us?
Yep. No problem at all. No problem at all. We have got, where are we now? So, with John Drapp coming in, one of our guys always kicking about, and he says he loves the old joke that Stanley Kubrick, did film the moon landings, but he was such a perfectionist that he insisted on doing it on location.
That sounds right too.
That's John.
It actually would have been cheaper to do it on location.
Probably
would have been as well. And we've got Digital Demonic Davros once again saying the trouble is the fact that we didn't go there. Oh, hold on, but the fact she didn't go there, you can't say we went.
Okay.
That argument holds no water.
Yeah. That's interesting.
Cool. And then Janie has commented that the political environment and how it was basically a dick measuring contest, and that meant the emissions stopped once the political conditions had changed. And John Rapp adds to that and saying the Russians did almost everything first. But do the deniers really think that the Yanks, Americans, would get away with fake landings?
Yeah, exactly. The Russians were way ahead, right into the early 60s. The Russians were so far ahead. The Americans actually thought they could never catch up. That was their feeling on it. But you know, and when the president came on and said, "Well, we're going to do this," that actually sort of put the firecracker up their behinds to get them going.
Mm-hmm. Yeah,
and then with all the
it was almost a mission of desperation because they didn't want the Russians to be first.
Absolutely, and they threw everything at it.
Yes.
Mm-hmm.
Yep.
And with all the previous flights, there was actually 9 Apollo missions that made it to the moon, 6 that landed.
Yes.
If you're gonna fake something, why would you go through such an elaborate way to do it? It is very hard when you consider that many missions making it to the moon, that to be able to hide that all 9 of them were fake and 6 of the landings that they made were fake. It from a logic standpoint itself, that is difficult. Yeah. There's not been one deathbed confession, not one overheard conversation, one leaked video, photograph, document in all this time. In basically 60 years worth of NASA work. So we can't keep anything secret. I mean, right up through WikiLeaks, the Bay of Pigs, the Pentagon Papers, Iran-Contra, Watergate, Abscam, Valerie Plame, Abu Ghraib. Nothing stays secret for long.
The current White House.
Yep.
Yeah.
But like the old saying goes, a secret held by more than one person is no secret at all.
Yeah,
that's right.
Exactly. But I think this whole conspiracy, it all starts from just a really extreme level of paranoia and just a small group of people who are convinced that there's one body, in this case NASA, who want to control the world. And they can't come up with a single viable motive or reason for doing so.
Well,
go ahead, Professor.
I was going to say, which is really uncommon to people like us, so, you know, who've been in the space industry and certainly sending satellites into space since 1975.
Mm-hmm.
So, you know, who do they think they are? You know?
Yeah, I have no idea what
years and years of work.
I have no idea what a conspiracy theorist thinks the motive is of all the space agencies faking things like this. They've never really said, and I can't think of a good reason for it. But one of the things that the one piece of evidence that we did go to the moon landing that I really don't know anything about is the ham radio operators who were tracking it. I've never played with ham radio.
I was just about to mention that. So the signals actually were transferred through Parkes, including the telephone call, this famous telephone call, which the flat earthers can't seem to understand what happened, even though it seems like they forget that it's radio. And this happens at Parkes in New South Wales in Australia. So we actually did handled the signals for the telemetry and actually came to, there wouldn't have been any video signal either, but for the station in Parkes. So, and the Australian ham radio operators are actually ham radio operators around the world who were actually listening to this themselves. So you can imagine those days, radio wasn't nearly as secure as it is now, so anybody could listen to it, and they did.
And Mike, I'd like to get your thoughts, weigh in on this. How does a ham radio operator know where a particular signal is coming from?
Well, it's you can figure that out by signal strength and direction, triangulation. Sometimes you would, even if you used a dish antenna, which is directional, so you get it azimuth and elevation right directly off of that. There's several different ways that they can determine the direction and location of a signal. It's not that hard to do. A hobbyist can actually do that themselves. You don't need any secret government equipment to be able to do those kind of things, especially not in that day, because the signals weren't encrypted. They weren't
exactly right. There was no security attached to it. So
they were lucky to even get it the signal strength they needed. So it was not as if they spent a lot of extra time securing the signals. And probably today with digital signals, it's much easier to do. But
yeah.
Exactly. I think people who like me, who haven't played with ham radio, have this assumption, and it sounds like from what you guys are saying, it's a faulty assumption that ham radio would operate like the FM AM radios, that where you just flip up your antenna, you turn it on, and away you go. It sounds like it's much more complicated than that.
No, you had to. You basically your antenna was shaped like a cross, and then you had to sort of. Or you had the ears, the bunny ears, and then you had to have them just in the right direction, and make sure that you held your mouth in the right direction as well. So, and then cross 2 fingers and 3 toes, and then you got your signal.
Yeah. When I was in the military,
and not to mention, if you have ham operators in 3 or 4 different locations that can get a generalized direction, you can then use that to triangulate an exact position.
Yeah.
As a radio operator, relay off each other
we used a long wire between poles or between trees.
Yes, that's it.
Connect to our HF radio, and we would adjust the length of that wire to compensate for specific frequency ranges and distances, and that's how we did it.
Yes, exactly. Yeah.
But I think the one claim from conspiracy theorists about fake moon landings is that tired old claim of it's all CGI, and none of them seem to understand that that's technology that was so far ahead of the time. They couldn't possibly have done it.
Yeah, apparently they believe NASA had CGI forever.
Yeah, exactly.
And that sophistication didn't exist.
Yeah, Babes and I last night were just watching an old movie filmed in 1969, released in 1970, called Marooned, and it was a story about astronauts living in space for 5 months, and all of a sudden their rocket engine didn't fire for the diesel burn, and they had to mount a rescue mission. And we were discussing this aspect of the fake moon landings when we were watching that movie, because their special effects were so bad. It was such a harsh outline around the space capsule. The Earth was obviously not photographs that they were using in those shots, but black and white stitched together things from low Earth orbit, or at times it looked like a painting. It was very, very obvious. Whereas when I look at the Apollo moon landings or footage of the Earth from the Gemini capsules, it doesn't have that type of harsh outline and black and white look. And you know what I'm saying?
Yeah, exactly. No, you're dead right. you can actually see that it is a photograph. I was just thinking about that computer graphics, and I was thinking about I did a course in Fortran at Melbourne University, and we didn't even have a screen in those days. You had this great big typewriter that you typed in it, and it clunked away, and then clunked back at you the program that you wrote. There was no monitor screen, not even that. So where on earth would graphics go? Think about this. Actually, the computer that we were using wouldn't have even had 16K of memory. Actually, it was 4K of memory, if I recall now. So we had to write computer programs in Fortran inside 4K of memory. So how on earth could you, how many pixels would you get together in 4K of memory? It's just ridiculous.
Yeah, I think part of the problem is that people today have gotten so used to Hollywood special effects, and they have gotten very, very good at it, that they tend to forget that things weren't always like this. And particularly with the younger generation who grew up with computers and all the cool special effects post 1977 Star Wars, who really began the invention of modern special effects. There's always with the younger generation the assumption that things have always been this way. You know, I was guilty of it when I was growing up in the 60s and 70s because I always had certain things available to me. And when my grandfather would tell me that, hey, I walked to school and had a horse and buggy, and we had an ice box where we had to put a block of ice in it. We didn't have an electric refrigerator. It boggled my mind when I was a little boy.
Yeah.
Exactly. There is one thing that I would like to pose to Mike. One of the claims that these conspiracy theorists often make is the fact that there was no moon dust kicked up during the LEM landing.
Are you reading my paper?
No, it's just a very common claim, and I was just wondering, Mike, what you had to think about that.
Well, of course there was moon dust kicked up. Just because you don't see these huge clouds or something like you would see on Earth, and not to mention that moon dust would travel much farther in a lower gravity environment and in an environment without all that friction of air, so you wouldn't see localized plumes that just hung in the air right around where it happens. So they expect to see what they would expect to see on Earth, and can't visualize that the conditions on the moon would be completely different. So you should see something different. It doesn't even occur to them sometimes. And when you do bring it up, they completely dismiss it.
Mm-hmm.
Yeah, I completely go along with that. That's the velocity, the takeoff velocity of any piece of dust up there would have been quite high, and they would have just shot straight up. There's no way for them to cloud, if you like, because there's no atmospheric resistance that normal dust would have, so that would bounce off and then come back down. This dust would just keep going.
Mm-hmm.
Right. And once again, I have gotten so engrossed in the conversation, I forgot to check our green room in the background. Ted has alerted me that he has other questions and comments.
Oh, brilliant. Thanks, logical mate. Thank you. Couple of questions and a couple of comments that I'll get to first. Referring back to the Gemini program, Digital Demonic Davros says that Gemini 3 was the first manned mission. So obviously of the 19, there was only the Gemini 3 onwards.
Yeah.
Brilliant. And then John Rapp was asking, with ham radio, that needs to be aimed, doesn't it? To which Janie had put a wee answer in and aimed the answer at Professor Phil there, saying that helical and Yagi antennas, which point in the direction of the transmission, were often used back then by the ham operators.
Yes, correct. Yeah.
And once again, Digital Demonic Davros is stated that also the time the signal takes, it was obviously helping us to work out exactly what was going on with regards to that. And then there was a couple of questions. One from 9 o'clock Hero saying, can you tell us more about the reflectors left on the moon?
Oh, yes. Yeah, we'll get to that. Yeah.
Fantastic.
The retro
And
reflectors.
yeah, brilliant, brilliant. And then we have one more question from they and them. He said, I have heard a suggestion that the NASA lies thing is just an anti-American propaganda and a way to try to turn people away from patriotism.
Okay.
And they would like to know the panel for their opinions on that.
Well, they're saying that we're lying too, so that's a problem.
Yeah, I don't think that's an anti-patriotism thing, because actually the fake moon landing conspiracy got started, I believe it was 1974, and it was an American who started it. I forget the gentleman's name, but he wrote a book about it. But it was just some ridiculous claims. But these claims started, actually during the Apollo missions. It wasn't even years later. The only thing I can think of is that this particular person was just looking for something to complain about.
Yeah, I was probably had something to do with the fact that there was quite a lot of Americans who were opposed to the missions in the first place, and they argued that it was a waste of money and the money could be better spent on this or that, and it was a waste of taxpayers' money. So they were against it already. So if there was any going to be any group saying it was a conspiracy, could probably came from that lot.
I agree. I think a lot of it is just Apollo was the thing. It was all encompassing. Everybody was talking about it. It was the biggest thing on the news, the biggest thing in the media, the biggest thing in educational institutions. Just Apollo was everywhere. And then some boob wanted to make some money off of that and decided to come up with some crazy notion that it was all fake. And well, there you go. Published a book and made his money.
Yeah, one of the things that amazes me about the history of manned spaceflight is that, space is the most hostile environment to human life that we know of. That with all of the man hours that we have put into manned spaceflight and the number of hardware and software failures that we had during missions, that no one has actually died in space.
No, that's
which is
that's pretty. It's a very scary thing to do, and I can tell you from this first-hand experience, the decision is not made lightly by the people who are responsible for putting missions together. Like I said, the one time that a person would die on the moon would be the last time anyone ever goes there.
Yeah.
It would be so horrendous. It would be there would be such negativity about it. It would be a terrible thing for any kind of space missions.
Yeah, that you're probably very right about that, and it's unfortunate because people tend to forget how many people die in car accidents, train accidents, airplane accidents, but we don't give those things up. Sooner or later, something's going to happen, a catastrophic failure. Someone is going to die in space. But if we want to make it to the stars, or even more locally to Moon and the Mars, I guess the question becomes, is the loss of life worth it in order to learn more and to do things better and safer as we reach further and further away from our home?
Well, that's a question, I reckon, for the person, the people who are doing it. And if you asked any astronaut, and if you asked any scientist and say, would you take the risk, and they would not even think twice.
No, they wouldn't think twice. I agree with that.
So there you go. So
it's also like any other endeavor. We've always explored, and there's always been loss of life in those explorations. Every time we, throughout our history, moved on to new lands, new continents, and
Yeah,
new frontiers, that it always came at a cost. Um,
yeah,
Honestly, in this particular case, somebody could probably make the argument that the dollar amount for such a loss is much higher, and the consequences are higher. But I think that in the end, you'll find that it's like no different than any other uh, exploration we've undertaken in our history.
exactly.
And
Yeah, exactly.
yeah,
Like
I think
going,
that
going for
yeah,
a
I think
dip.
that that's to be expected, and I think that we should, you know, it should not deter us, because sooner or later we're gonna have to expand beyond the confines of this globe. That's
Yeah,
something
yeah,
that needs
exactly.
to be considered for the future of mankind.
And the cost of letting it deter us would be even higher.
Yes, it would be.
Yeah. So, what do you think about the stars? Not being able to see the stars. So one of the things they
Oh,
complain about
that's a
is
silly
the
claim.
stars.
Yeah,
Yeah,
yeah, that's a silly claim.
Yeah.
Anyone with any kind of basic knowledge of how a camera works
Yeah.
and f-stop settings on your camera,
yeah. And
that's
that's
so
actually
easy to
something you can
explain.
replicate yourself
Yeah,
here on Earth. I mean,
yeah.
you can set up a camera at night and take a picture that includes the stars, and
Yes.
then provide a bright light source. Take the same picture of that person, and lo and behold, you're not going to see the stars. The,
Yeah.
ex-
Exactly.
the shutter speed is so much faster, and there's a relationship between the shutter speed and each increment, and for the f-stop, each increment either doubles or halves the amount of light getting to either the sensor or the film, depending on what it is. So what winds up
Hmm.
happening is the shutter speed so much faster. You
Mm.
close down on the aperture because now you have a lot more light.
Yeah.
So you only get the most brightly lit objects. Things that are dimly lit, like stars, we know they're dimly lit. I mean, at dusk you don't see them, but in stark dark night you do. So it's the same thing. You don't see them during the day for the same reasons you don't see them in a brightly lit foreground and the stars are in the background. It's basic, and it's also something you can replicate here on Earth. So there's no
Absolutely.
mystery to that. And if you're going to make the claim without testing it yourself, you're out of gas.
Yeah,
Well, yeah.
yeah.
Well, I could add too that in the because I mean it gets to be nighttime as well. I think they forget that, and so in the daytime you can't see the stars, just like you can't see the stars from Earth. Why would it be any different? And in the nighttime you can see the stars, and in fact they use stars in the missions, and still use today for positioning.
Mm-hmm.
So if you have to use the stars because you're looking at parallax, you're looking at measuring distances and stuff like that. You're using stars to do that because you
Yeah.
can rely on the fact that they move so little compared to us that we can rely on them for positioning.
I think for the conspiracy theorists, there's a faulty assumption in their thinking in that in space, it's always night.
Yeah,
It's not true. It's only night if you're behind something in the shadow of the planet, the shadow of the moon, or the shadow of your
yeah,
spacecraft. That's what creates night. Just because the sky is black in space
yeah,
doesn't mean it's completely dark. There's a big ass star only
yeah,
93 billion miles away pumping out a
yeah,
lot of
exactly.
light.
Yeah.
Yeah, exactly. Anything in its path will be lit up.
Yeah, what gets me a lot about a lot of these photographic claims, how directions to shadows and all this other stuff. These are actually things that those conspiracy theorists can go off and actually do themselves and check for themselves. And it's amazing how you could be visually tricked when you have some object casting a shadow, and you'll see shadows going off in funny directions, even here on Earth, because if the ground that shadow's laying on isn't perfectly flat, if it's rotated, if it's peaked, if it's running in different directions than the ground the object is on, the shadows will look completely different than what you would expect. And these are things that people can go off and check for themselves. So it's all that stuff, all the photographic quandaries and anomalies that everybody complains about are easily verifiable and easily checked.
Yeah, one
Yeah.
of the favorite arguments of those conspiracy theorists is the fact that they can see shadows falling in different directions on the moon.
Yes.
Well, that's explainable again.
Yeah, as a matter of fact, that same MythBusters episode, if I remember correctly, also did a segment on shadows and thoroughly debunked any idea that they were faked.
Mhm.
And again, it goes back to the thing is, if you're gonna go through all the trouble to fake not only one but 6 moon landings, then why would you be so incompetent about it?
Yeah.
So I haven't been sort of around these flat earthers long enough to know this, and perhaps if you can give me some advice on this. The flat earthers tend to, I've heard them use this, a film, which I haven't actually watched, and it's called Funny Thing Happened on the Way to the Moon. They use that film as some sort of reference. I've heard them use that as something, especially this Globelite tour thing that's happening in Europe. They use that as a reference, and I'm thinking, well, I'm pretty sure the people in, from what I know of, from what I've heard about this film, they don't actually dispute that space exists. They just dispute that we went to the moon. So there's a contradiction with the people who they want to use this film as a reference for debunking the moon landing, and yet this very same film doesn't dispute the fact that even manned missions happened.
Well, not every conspiracy theorist who denies the moon landing is a flat earther. It's kind of a progression in conspiracy theorists, right? So not all moon landing deniers are flat earthers, but all flat earthers have to be moon landing deniers. So I think that's where some of that's coming from. But I have not specifically seen the film that you're referencing, Professor. Jeff and Mike may have. So what do you guys know about that?
I've seen parts of it.
I've seen bits and pieces of it. Yeah. Go ahead, Mike.
I'm sorry. I've seen bits and pieces of it, but I haven't seen the whole thing. And it is not atypical of conspiracy theorists and flat earthers in particular to use sources as reference for a point they're trying to make, while using this same source as reference to prove the globe is a lie. So there's a whole lot of contradiction going on there anyway. So yeah, it's not unusual for a flat earther to use a source that assumes and claims the world is a globe and space exists to show whatever point it is they're trying to make. Sometimes they really don't care where the source comes from.
Yeah. And then
they're just basically misrepresenting some original Apollo footage and trying to spin it in a way that goes that supports the claim that it was fake. Kind of like the thing you'd see on Ancient Aliens.
Yeah, I'm not going to say it was aliens.
Yeah, and with that, Taddy has alerted me that we have some comments and questions from the live chat. Taddy?
Yeah.
Well, thank you. Once we look, see here now. Where are we? Yeah, here we go. So once again, we have a question from them saying, why do you think that space deniers refuse to accept what we understand about light and the way it travels, and why it's not applicable in space? He also
I've got a little bit of a lecture on that if you later on.
No problem.
If you'd like to listen to it.
I shall if you can chuck me the link, we can put it into the chat for it.
Oh no, I'll do it right away. I'll do it right here.
Nice one. Oh, brilliant. Even better. We can get that done.
Sure, we'll get to a little bit of that as Taddy finishes up his comments. Taddy, go ahead and do that, and then we'll let the professor weigh in with that bit of lecture.
No problem, no problem. Then them also saying, with regards to the film, a funny thing happened on the way to the moon. Is saying that Gem Panda has done a great debunk of that. So maybe go and have a wee look at that at some point if you're interested, Professor.
Yeah. Okay. Yeah. All right. I will do. Gem
And
Panda.
Gem Panda.
Okay.
I'll
Right,
find it.
okay.
I'll get the link to you.
I'll just. Okay. Please. Yeah. Okay. Thank you.
Get the link to
All
you. No
right.
problem there.
Okay,
And-
so one of the things that they I'll come to the light thing, but one of the things they talk about is the Van Allen belt.
Mhm.
So are you guys familiar with that?
Yes.
Yes, sir.
That was in 1958. Well, that was discovered. So that was 11 years before the moon landing that they actually knew about it. But as a physicist, I've done quite a lot of work with radiation and light, and that's why I'll do this thing on that. So we can talk about radiation, light, and why that the Van Allen belt is not a problem. It never has been a problem. Isn't a problem now. It's not a problem for humans and for shielding. So what they're talking about is cosmic rays that affect modern electronics. Has nothing to do with not being able to shield from that, because they can. Not only that, they actually know where these where the Van Allen belts go and can avoid the worst parts of it. So anyway, I'll if you want to have a chat, I'll set up my board there, and we can go through a few things and maybe just do a little bit of physics on light.
You're on full stream, Professor. Go ahead.
Okay.
Lovely floor.
Okay, so how can we see this from here?
Yes, sir.
Yes,
indeed.
yes, you can.
All right. Okay. Yeah. Okay. That's good. All right. Well, let's start off. First of all, we'll talk about this Van Allen belt. So this is the Earth, and basically what happens is you've got this like a torus that goes around the whole Earth. That imagine this going right around the Earth like this. Okay. So it's now to get away from it. It's just a matter of America sort of, right around here somewhere. Getting away from it's not difficult. So this is like a trajectory like this would easily get away from the Van Allen belt. So the fact that it's there, you don't have to travel this way, and you never would anyway. So even in any kind of orbit, you'd always be starting. So if you've been in India, you'd either head south, which is mostly what you do for a polar orbit like this, or you'd end up for a geostationary orbit. You'd end up towards Indonesia, around back through South America, and then over Kenya. So around that way, and that would get you into the elliptical orbit before you go into the transfer orbit for geostationary orbits. That would go that way. There's no reason to actually go through the belt this way and then for long exposures. This is the way they go in America, and they'd head up this way, away from most of it. But now, as far as shielding goes, so one of the things they argue about is shielding, and say you'll need all this lead. Well, you won't, because we're not concerned. It's not the short wavelengths that we're worried about with the Van Allen belt. They are alpha and beta particles. These alpha and beta particles can be stopped by a piece of paper, let alone shielding, other types of shielding. The other thing about it is metals would actually have a detrimental effect, because metals would actually cause, if you fire an alpha particle at metals, then it releases X-rays, which is precisely what you don't want to happen. So the best the best type of stuff for shielding against alpha and beta particles are going to be paper and plastics and stuff like that. Okay, now let's have a look at the electromagnetic spectrum. Okay, now first of all, and this will lead on to this idea that the moon has its own light. Okay, so we're talking about light, so we'll go through that particular thing with the moon has its own light. But when I go through this lecture on what light is, it will be plainly obvious straight away why the moon cannot have its own light, so, let alone all the other issues that deals with it. Okay, so the electromagnetic spectrum is basically, we're talking about photons, and we're talking about photons that act like particles, if you like, and act like waves. And in fact, these photons are packeted in wavelets. Now, they start from long wavelengths, which is kilometers long. So I'll try not to get in the way. Long wavelengths, kilometers long, and to get to very, very short wavelengths, extremely short. And when I talk about short, I mean nanometers. That's 10 to the minus 9. So you're getting over here with kilometers, 10 to the 6, and then you're getting all the way down here, and you're getting down to so 10 to the 3, which is kilometers, and then 1,000 kilometers, 10 to the 6. And then you're getting all the way down here, and you're getting 10 to the minus 9. So we're talking about nanometers. We're talking about very, very small wavelengths. Well, sort of bang in the middle of that, within that is visible light. Now, the thing about this visible light, this is all the same stuff. And the only thing that makes this visible light different from the rest of this is the wavelength and the frequency. So that's what makes that difference. But this is the same stuff. It's like everything is made out of atoms, and atoms have protons and neutrons. Well, all protons and neutrons are the same. The only thing that differentiates one element from another element is how many there are. So more neutrons, more protons, that makes it different. You've got, so if you've got seven neutrons, 7 protons, you've got nitrogen. If you've got 8, you've got oxygen. The difference between nitrogen and oxygen is just simply it has an extra proton. If you could take away the proton away from oxygen, you'd have nitrogen. If you could fuse a proton into nitrogen, you'd have oxygen. You could turn lead into gold if you wanted to, by simply removing three protons. Obviously, that would cost a lot more than it is to simply get the gold. So that would never happen. Okay, so back to the light. Now, the thing about it is that this is all the same stuff. How do we know what the sun is doing? We know what the sun is doing because it gives off this electromagnetic radiation. For us humans, we're very lucky because the sensors in our eyes can pick up this band over here, which is visible light. My jacket is blue because the blue light is being reflected off it. The rest of the light is being absorbed. And when I talk about light, I'm talking about red, orange, yellow, green, blue, indigo, and violet. So what's happening with my jacket is this part of this electromagnetic spectrum is being absorbed. All of this part, is being reflected. All of this is being absorbed. This whiteboard is white. It's white because all of this here is being reflected. None of it is being absorbed. Something is black That's black because all of the wavelengths are being absorbed. None of it's being reflected. So you can't see anything. You can't see any color there. You see the black. It shouldn't be a surprise that when you look up in space, it's black. Okay. Now, when we think about light, the moon having its own light, and they're saying that the light must be cool. Well, there is no other type of photons. There is no other type of light. And any one of these produce energy, and any of this energy would have a degree of heat. So nothing gets colder. Cold is really just lack of heat. So anything over here would produce heat, would produce energy, more over here, less over here. But there isn't a special type of moon photon that could produce a cold light. So that straight away tells us that's impossible to have the light on the moon. So that's it in a nutshell. Just in case you want to know what these other rays are, radio, microwave, infrared. So the radio includes FM, AM, so amplitude modulated, frequency modulated. Then you've got here, back here, you've got microwave, infrared, visible light, which is what we've developed our eyes to be able to see. Beyond that, ultraviolet, X-rays and gamma rays. So this very, very high frequency radiation, this is extremely dangerous to us. And thankfully, for Earth's magnetic field, if you like, I think we're going to have a chat about magnetism. Glad to do that. Thanks to Earth's magnetic field, we are protected from this part of the electromagnetic spectrum. Otherwise, there would not be any life on Earth. So that was a quick lecture on light.
Well, Professor, I really gotta say, I love watching somebody teach who really enjoys teaching. In fact, we have a gentleman in our live chat right now by the name of Dutch Heretic, who is a science fiction writer, and he's asking whether or not he'd be able to consult you as an expert in helping to create his manuscript.
Glad to do that. More than happy. Yes. You can share my email if you like. No problem.
Alrighty. Well, after the show, then I will make sure that I send a private message to Dutch Heretic in Discord, and we'll get him your email. And so, Mike, Jeff, do you want to jump in with the conversation, or do we want to go to Taddy for comments? I think he has a few.
I do want to.
Go ahead, Mike.
One thing. I completely agree with what Professor Bell was saying. And in my former life, when I was in the Navy and in commercial nuclear power for a few years after that, I worked in radiation health physics. We had this mantra, time, distance, and shielding for reducing people's exposure to radiation. And that's exactly what he described they do when going through the Van Allen belt. Time, you go through it as fast as possible, and you go through areas that have a minimal cross section so you can pass them as fast as possible. Distance, well, you maintain your distance from the highest radiation portions of it, and so you go through the lowest radiation fields, and then shielding. He's already discussed that. Most of the particle radiation in the Van Allen belt is beta and alpha. Alpha is basically just a helium atom without any orbital electrons, and then and a beta is an electron. So what you get is it's shielded by paper and by clothing and plastic. All of that is enough to shield those types of particles. So it's pretty simple. The Van Allen belt's not a problem. Even Van Allen himself stated that the conspiracy theories that it was impossible to pass through the Van Allen belt was the silliest thing he ever heard.
Yeah, it
That's
is pretty silly. And again, more faulty thinking and thinking that all radiation must have lead in order to stop it. And like you guys are saying, a simple sheet of paper can stop some radiation depending
Yeah.
on its wavelength. And Teddy, let's go ahead and get to some of those comments and questions in the live chat.
Yeah, no problem at all. No problem at all. Once again, in keeping with the previous conversation there with Dutch Heretic, he's saying, I'm going to paraphrase here, says, he always says there is nothing that is absolute darkness. It's only our own inability to see the whole
Yes,
electromagnetic
that's exactly
spectrum.
right. That's exactly right. Probably I could have mentioned this as well when we talk about looking at stars. So one of the ways that we look at stars is we're looking at the stars and we're looking at the visible light part of the spectrum. But there's much more than that that's coming from those stars, and that's for instance radio. So it's possible to build a picture out of radio just as easy as it is to build a picture out of visible light. The instrument doesn't care whether humans can see this or not. It's all about whether this instrument can detect those wavelengths or not. So those wavelengths are all the same stuff. So whether you build a photograph out of infrared, or whether you build a photograph out of radio, makes no difference to the instrument. It's still photography. It's just that we can't see it as humans because we can only see visible light.
Exactly right.
What's that?
And with regard to the Van Allen belt, when it comes to human physiology, the only radiation they're really worried about is gamma rays. And they got so little exposure, they were hardly affected at all. Isn't that right, Mike?
Yeah, and X-rays too, yeah.
That's pretty much true. They, I think it amounted to 1 or 2 standard chest X-rays. I've gotten more documented exposure in my my lifetime in nuclear power than they received from these flights. And that's typical. Most people who work in nuclear power have gotten much more whole body radiation than any astronaut ever has.
Mm-hmm.
Yeah, and that's one thing that I heard conspiracy theorists say from time to time is that 1 or 2 of the astronauts got cancer from the Van Allen belts, therefore we couldn't get through the Van Allen belts to get to the moon. But, did the astronauts get cancer because of the Van Allen belt? Well, who knows? There's so many variables that goes into the development of cancer that's really, really hard to say.
Yeah, I hate those
exactly,
sort of leaps from one thing to another. It's like saying, all crows are black and all crows are birds, therefore all birds are black. It's just a ridiculous analogy.
Absolutely
unsupportable.
ridiculous.
Okay, all right.
And earlier we did have a
Wonderful.
question. I'm sorry, Taddy, I just heard you try to break in. What'd you say, sir?
Oh no, it's just it wasn't really a question. Was a couple of extra comments. One was purple rhymes with orange. He says, "I'm also working on a science fiction novel. Trying not to break any known laws of physics, so nothing moves faster than the speed of light, which means
That's
decades for a ship to go between ghost star systems." And he says his biggest problem is being realistic about the time. Time
okay.
makes things. Or I'll try that again. So I put my teeth back in. The biggest problem is being realistic about time makes things kind of boring. It will take more than 20 minutes before someone with a telescope on Earth would be aware of a ship exploding near Saturn.
Yes, yeah. The thing about it is it's like the argument about whether aliens have come to Earth. And my view is that unless we have evidence of some sort of wormhole, then the answer is no. And the reason is very simple. Using Einstein's equation, E = mc squared. The fact is, you would need to be the size of an electron to be able to travel the speed of light. you would need to travel the speed of light if you had any hope of getting to any star inside 400 years. So what creature is going to survive 400 years with the sustenance that they need to be able to come to a planet that they probably don't even know exists?
Exactly. It's just so unlikely.
Right. And there was a question in the chat earlier about the reflectors left on the moon by the Apollo astronauts, and we promised them we would get to that.
Okay, well, we actually use the reflectors in ordinary everyday business, and the reflectors. There's actually 4 of them on the moon. Actually, there's 5 of them. One of them's in bits and pieces. Was sent there by Vikram. As you know, it crashed just recently. But yeah, the reflectors. Let's see, they come from, first of all, the first one was there by Apollo 11 mission. I can actually give you the exact coordinates of where this reflector is. And they call it the Lunar Ranger Retro Reflector, so LRRR. If you want to have a look at that, look them up. And by the way, Buzz Aldrin is the guy who actually put it there, physically installed it. Others by Apollo was one was Apollo 14 put a reflector there in 1971, and Apollo 15 put the one that's currently used by most universities and agencies like us that are used at. Now that reflector is a vital piece of equipment because there is no place anywhere where we could test a laser anything like thousands of kilometers away. There's no place on Earth you can test something that's thousands of kilometers that's you trying to send away in a straight line. So it's really handy that the moon is up there and the moon has these reflectors on it. That means because if we want to calibrate a laser, a long-ranging laser, then this is obviously the place the only place that you could do it. So because of these long-ranging lasers, by the way, they pulse lasers. So I think people tend to think that it's a laser, it's just a fixed light that goes all the way there and comes back. It's not like that. The lasers that there are sent in pulses, in packets again, like I described before. And these packets are obviously highly timed, and we know the frequency at which they send them. We know the frequency of the wavelength, that is, and also the frequency of the pulse. And then when they come back, if you're getting the same frequency of the pulse and you're getting the same frequency of the wavelength, then you know that you have the same signal that you sent up there. Now you have to have a retro reflector because the type of stuff that's on the moon, the type of dust that's on the moon, I actually wrote down, because I can never remember the name of the stuff. Does somebody remember what that moon dust is called? Anyway, it's a highly reflective dust, mostly silicon and oxygen. So oxygen is and the silicon are the two prevalent elements on the moon, and they're quite highly reflective. But the trouble is, they scatter lights, so the light would be very highly scattered, which is a good thing. Otherwise, we wouldn't get the moonlight that we get. But with the retro reflector, what happens is it's designed to be able to return a beam no matter what angle you're shooting it from. Otherwise, everybody would have to go to the same observatory and fire off laser at the same place. But because the retro reflectors are designed to be able to return a beam no matter which direction that you fire it from, therefore from all over the world, these retro reflectors can be used. Now these are used all the time. So if any flat Earth person or denier wanted to know, they could easily visit one of the observatories that have the laser that actually does this. If they don't do that, then they are willfully being ignorant. So this is number one proof that people went to the moon.
And Mike and the professor, we have a question from they and them in the live chat concerning the statements about the wormhole. It reads, if we could create a wormhole, I heard that it would collapse if we were to try to travel through it in a spacecraft. Is that correct?
Yes, because see, what you got to consider is gravity. It would be like if you fell into a black hole. Okay, so if you fell into a black hole, it would basically stretch you and stretch you, try to stretch all your molecules apart. That's kind of what that effect would have, that gravitational effect. So we're thinking, you think that's probably how that that might happen in a wormhole as well. So again, we're just speculating, but it's an interesting thing. You know, there's people who in departments in universities who actually study this stuff. So it's, you know, it's not like we in universities, they don't entertain wacky ideas. Wacky ideas are good as long as you're not dishonest about looking at evidence that goes against your wacky idea. And this is the problem with flat Earth. Flat Earth people might have some wonderful, you know, one of them might come up with some good ideas and some good ways of thinking. Not that they use it to prove that the Earth, or to speculate that the Earth is a globe, but it could be useful for other things. It could be some idea about magnetism, for instance. But it's all going to be lost. All of that's going to be buried in the lies and the ridiculous things that they say and the ridiculous conspiracy theories that they bring up. If you drop all the nonsense, take your good idea to the academics, and they'll say, yeah, okay, we're not against looking at good ideas, no matter how wacky they are. Just don't be dishonest about it. This is science. You can't make stuff up.
Yeah, and
Absolutely.
I had an interesting conversation yesterday morning with they and them in the background, and part of what we were discussing is evidences that could be accurate for either model, you know, sphere Earth, flat Earth. You know, and the conspiracy theorists tend to latch on to those and forget the other evidences that dispute their flat Earth model. And one of the evidences that I think is along those same lines with moon landing deniers, and I've seen many moon landing deniers use it in order to say it was all fake and done in a studio, is the Galileo drop from Apollo 15, where they dropped the hammer and the falcon feather. Now, granted, I do know that that can be reproduced on Earth.
Yes.
But what about that footage from Apollo 15 tells you that that was actually performed on the moon and not on an earthbound vacuum chamber?
Well, first of all, if it was in any kind of vacuum chamber, all the vacuum chambers that I know of are you can see they're visibly contained. There's no way you can I mean, it's an expensive thing to make a vacuum chamber, and so you know, I think the largest one is at NASA, but this is we're talking about a multi-million-dollar affair, or even more than that, hundreds of $1 million worth of equipment, hundreds of millions of dollars worth of equipment just to show you that a feather and a hammer will drop at the same time when we already know it will. By the way, I brought my ball over here to show you why it does, if you're interested.
Oh,
So,
well, certainly.
If you think about this ball, the curvature of space-time, okay? So space-time is about time moving along, and then you've got position. So there's time and position. Position is actually in 3 dimensions. So when you look at the position part of the position part, So here's the grid. There's the grid. And what we're looking at is we're looking at time, if you like, going across this way, and position going this way. Now, if you don't move, physically move, then you are definitely still moving through time. Now, position is a three-dimensional thing. So X, Y, so you got X, Y, Z. So this is three-dimensional. Now, as you go through, when you start moving, you're now moving through space. As you're moving through space, you're actually also moving through time. So you're going to move through a curve. Because you're going through time and space as well. So you're going through this position and you're going through time. So you must also go through a curve. Well, you think, well, why do things to fall? Imagine if this was, by the way, if this curve went on indefinitely, then we would be looking at an ellipse. From an energy point of view, the curve is actually a straight line. Look at this ball. Here is the equator. Oh, by the way, there's the flat earth person called Phi. Now, so I'll put it closer there. There you go. All right, so this equator around the ball, if I take any two positions, so imagine now that this space-time is now represented by this ball. It's curved. If I start at any two positions on here, I need to move in a straight line to be the most efficient in both of these positions. So I put my two fingers here on the ball and I move them in a straight line. This is a curved line. This is a straight line around the equator. So if I move them in a straight line, they come together right there. Therefore, this is the same as if I drop two things at the same time. They must go straight down towards Earth's center of mass. That is the most efficient way for them to fall. They don't fall in a curve like this. So therefore, they fall in a straight line as they go. This is a straight line on the curve. The straight line takes you straight to the center. Both things, regardless of their mass, will fall at the same time. Okay.
Additionally, such a thing could not have been faked in a vacuum chamber. They ascribe technology to what they believe these videos are showing them. The ability to be able to do the type of green screen CGI that it would take to do that in the NASA's vacuum chamber facility and make it look like it's on the moon just plain didn't exist at the time. It barely exists now to make it that realistic. So yeah, from multiple different fronts, that whole argument is just crap.
Yeah.
Yeah.
The motivation to justify the cost, it wasn't there.
No.
And there is a couple of comments in the live chat that caught my attention. Sorry if I'm taking your job there, Teddy. But Dutch Heretic says, wasn't it Stephen Hawking who once said, scientists need sci-fi writers for inspiration? Scientists usually lack imagination. And then John Rapp follows up with that, wanting to know, Professor Bell, do you read science fiction? If so,
No.
who are your favorite authors, and did anyone inspire you?
Asimov.
Oh yeah.
Yeah, so
Classic.
I'm talking about stuff that's a while ago. Obviously, I do love science fiction, but the thing is, I'm a bit spoiled because I look for stuff that's wrong, and that kind of spoils it sometimes. So, so if somebody says something and I say, well, no, that's not right, and then I kind of feel, I have a bit of a bad taste about that, and I feel like bringing the producers up and saying, now, can you please correct it? But then I forget that this is a film, so it's going to be wrong in many ways.
Yeah, and then they and them just said, if time travel was possible, would you also have to accommodate the movement of the planet, or would it not matter? Just thinking about that quickly, I would think that yeah, you'd have to take in all aspects of the planet's moving and where things were or are going to be in much the same way traveling to the moon. We're not aiming directly at the moon with the spacecraft. We're aiming where it's going to be when we
Yeah.
get there. It's an intersect path.
Yeah.
Yeah, actually that's a very complicated thing. It's called LTI, so the lunar trajectory intersection injection. That's what it's called, and basically that involves doing a few orbits around the Earth till you get enough velocity, and then making a small burn that will take you out away from that orbit, and then moving in an S shape towards the orbit around the moon. And as you said, you've got a plan for the moon where it's going to be at any time, and then you've got to do quite a few orbits of the moon, because as you've got to remember, as you come closer and closer to it, you've got to try and slow down as well. So this is a very, very complicated thing, getting to the moon.
And I was in a live chat of a live stream a few days ago, and I threw out a little statement, fun fact, that they were discussing how Voyager did a speed bump against Jupiter and all that, and I was mentioning that when a spacecraft does a little speed assist with a planet like that, that it transfers energy and momentum from the planet to the spacecraft, thereby slightly slowing the rotation of the planet by as much energy as it imparted to the spacecraft. Someone else in the live chat tried to dispute that with me, so I'd like to get Mike and Professor to weigh in on that particular thing. I just want to make sure that I'm actually correct with that, or not.
You are correct, and
100% correct.
it is just straight conservation of momentum.
Yeah.
So the transfer of energy, the orbit of that planet slows down, but it's calculable, but it's not something that's measurable. However, the much lower mass of whatever the spacecraft is, when that conservation of momentum happens, actually results in a rather significant velocity increase of that spacecraft. Yeah, it sounds. Most of this is calculational based for the planet parts. You can't actually measure the change in its orbital velocity. But conversely, if you approach the planet from the opposite direction, you could actually use that same conservation of momentum principle to slow the spacecraft down.
Yes, that's right, exactly. And that's what we do.
Yeah, so, and when you watch the path of the Apollo missions, they leave Earth's orbit in one direction and then come at the moon in the opposite direction, using for that reason.
To slow down. Yeah, exactly. So the moon is actually slowing the Earth down.
Yep.
Okay, so the Earth is actually slowing down. The spin of the Earth is actually slowing because of the moon, because of the tidal effects of the moon. So that the moon is slowing down because of the way it affects the water that's on the Earth. And I can give you a bit of a spiel on how these tides work, but one thing I just say at the top of that, and that tides affect everything that's got water. So it even affects humans. So the water in your head is affected. So I was just thinking about this, that the amount of effect that's in your head is proportional to the amount of brains that you have. So I was thinking that no wonder the flat Earth people are not particularly believing of the moon having an effect on tides.
That's kind of funny, which kind of leads us into that question that you got on your channel there, Professor Bell, with the conspiracy theorists claiming that the tides are electromagnetic in nature and not gravitational. What do you have to say about that?
Okay, well, I think it's worth I think it's worth talking about what magnet is, and this is the silly thing about what what the flat Earth people are saying, particularly that one. I'll just get some of this off the board. Okay, now, so Faraday, very famous scientist who had a lot to do with electricity, as you know. He had a tube, just a cardboard tube, you know, paper tube, and he had a magnet, north and south, and around here put a coil, and this coil was attached to an ammeter, and all he did was nothing else, threw this magnet down this tube, and lo and behold, created electricity through this ammeter. So did nothing more than that. It's a tube, a coil of wire, something to measure the electricity with, threw the magnet down here and created electricity. Well, that was quite amazing, because what people thought was, if you can do that, why can't we find a way? So the engineers now came in, so Tesla, and now the engineers, the scientists do their bit, and the engineers come and do their bit. The engineers are saying, well, how can I get this magnet to keep going around like this? And of course they thought about it and said, well, why don't we just make the magnet stay still and put quite a lot of them like this, and get the bit in the middle, the coil, to do the moving. And of course that worked. So what do we have here? An alternator. A generator, electric generator. That's because we're moving this around the magnet. It's the same as if we were throwing this magnet down this tube continuously. Now that's creating magnetism. This is creating a magnetic field around here going through an electric field. This works the other way around as well. So if you get a bar of steel and you wrap a coil around a bar of steel, connect it to a battery, and you will create a magnetic field. It's exactly the opposite. So this is electromagnetism. Now, I'd like to see how you make this work on the sea. How on earth do you get that to work on that? That's what electromagnetism is. So, what are they saying? For somehow there's some sort of polarity over here and some sort of polarity over here, causing this to be bulged out. Well, that just doesn't seem anything like what electromagnetism is. This is what electromagnetism is. The other stuff that I explained is the electromagnetic spectrum. Totally different things. By the way, just as a matter of interest for those who are interested, why is something magnetic? Probably most people remember this, and that is the crystalline structures. If it's just higgledy-piggledy like this, like aluminium or plastic or anything like this, these are higgledy-piggledy everywhere. You cannot be magnetic. But if you could get these crystalline structures to line up. And as soon as you do, this creates a magnetic field, and in that bar looks like this. Okay, and that's north, south, going from north into the south. When you look at Earth, rub this off. When you look at Earth, Earth is like having this same bar magnet right down the center of it. And this bar magnet, again, this time it's south and north this way. So magnetic north is actually at the South Pole and magnetic south is actually at the North Pole. And again, the magnetic lines, which are saving us from all of those X-rays and gamma rays, going around the Earth like this in 3 dimensions, so all over the place, protecting us. That is the magnificence of what's happening around us. But for this, we wouldn't be here. But of course, that's all very well to say. In fact, but for this, we wouldn't have evolved. There you go.
Yeah, but the only thing I can think of that why a conspiracy theory keep trying to claim electromagnetism with the tides is the fact that water is electrically conductive, but it is not magnetic. And as you just described, those are 2 different things.
Yeah, it needs to be like that to be magnetic. And you need to be able to align the crystalline structures. We can't even make aluminium magnetic, let alone the sodium chloride. Because when you think about it, just because it's got ions in it that allows it to conduct electricity, doesn't mean that it's got the facility to be able to become magnetized. So it absolutely doesn't make sense. Anyway, the main thing is we do know why the tides are, and it has nothing to do. It's totally and utterly explainable, and nothing to do with magnetism.
This is where we would insert the clip from Desert File.
Yeah.
Absolutely.
Yeah, and the professor probably isn't aware of Desert File, and just in case he's not, Desert File is a debunker that's been around for a very long time. And about 9-ish years ago, he apparently got frustrated in one of his videos, and he started screaming at the camera, "Gravity, you morons! Have you ever heard of gravity?" A lot of debunkers use that in their videos. It's hysterically funny.
Yeah. Okay.
Yeah, it's become a real staple.
I'll have to look out for that.
What gets me is these people, they think that it's magnetism that's causing the tides. Can you imagine the power source required to turn the moon into a magnet?
How many Tesla would that have to be?
I think it would kill everybody.
Unimaginable. It would kill every human on the planet.
Well,
in fact, I think our 2 planets.
Electromagnetism as a replacement for gravity just doesn't really make any sense, because there are things that aren't magnetic, that aren't affected by magnets. So how do you explain that all away? You can't. And they just ignore that fact because they want to presuppose gravity doesn't exist and create some magical data to fit a conclusion instead of drawing a conclusion from real data.
Yeah, it's great that they ask the question, but then they don't accept the answer when it's provided. So that takes a good question and turns it into a bad question as far as I'm concerned. And John Rapp in the chat said, speaking of magnetism, the South Magnetic Pole is actually a physical North Pole. Well, that kind of just blew my mind.
Yeah. Yes. Well, actually, it's quite easy to, if you pick up a compass and that little red part of the needle is actually the North Pole of a magnet. So that little needle, which is half red and half white, if you like, is just really a little magnet. Okay, and the red part that points north is really just a magnet. So it must be pointing to a south pole in order to point to a north, if that makes any sense to you.
Yeah.
Actually, explain that way, it kind of does. Yeah.
Okay. So it goes to show that it is the magnetic south pole that's at the North Pole.
Yeah.
And although we're waiting there at some time, who knows when, maybe a few thousand years or maybe less, we never know when it'll happen, but we expect that to shift. So in other words, it will completely flip around.
And
It has
Mike, you were
once
just
already,
saying,
has it not?
Yeah, it has actually flipped several times through history.
Yes.
It's measurable in the geological record.
Mm-hmm.
yeah, the Atlantic Rift has been a good source of information about the magnetic pole shifts over the course of the Earth's history.
Yeah.
I was just watching a documentary about that a couple of months ago. It was very interesting.
Yeah. And Professor Bell, well, in your estimation, what would be the difference between the magnetic fields around the moon and those around the Earth? Like, the Earth would
Okay.
surely overpower
Look,
anything the moon could produce.
There is a magnetic field around the moon, but it's absolutely tiny compared to Earth. The reason is because Earth is a moving has actually got a moving core and a moving a magnet, one that moves against each other. See, the whole thing about what I explained to you with Faraday is electricity and magnetism doesn't happen unless there is movement, unless you get movement. So
Yeah.
I'll just pick up my pen. This might be fine. You might find this interesting. Okay, so imagine we've got two magnets like this and a magnetic field in between them. So these are two magnets and there's a magnetic field in between them. And here we have a coil. So we can put many different terms in that if you like. There's a formula for that, by the way. F equals N number of turns by the current, by the length of this coil. So in other words, it matters how much wire is in the armature by the amount of the magnetic field, which is in Tesla. So this gives, that is the formula. Now, have a look at the AC graph. Almost everybody has seen this before. This is AC current, okay, as a sine wave. Now, watch this. When this coil is parallel with the field, then we're over here. As we turn the coil around, as we turn it around, we are now increasing the voltage and the current going up. So as this turns around, imagine that's going around now. It's increasing. This is the maximum at 90 degrees. So when this is 90 degrees, this is the maximum. Now it keeps turning, comes back down again, comes back to zero when it's parallel again. Then off it goes down here, same thing, minus voltage, plus up here, and then goes back up here. This is what happens. It requires this to move. Things have to move in order for, through the magnetic field, in order for voltage to be created. The same thing happens with the Earth. Because we've got a core and we've got this moving against each other, creating movement, this doesn't have to be magnetic. It just has to move past each other to create this electric field. And this electric field, as you can see from here, creates magnetic field. Okay?
Very interesting.
And I really enjoy our audience. They really offer a lot of good comments and questions, which really drives our conversation forward during these shows. And the real non sequitur just asked, what are the forces that make the magnetic poles shift? That's way above my pay grade. So I'm going to let Mike and Professor Bell talk about that.
Yeah,
Look,
it's
one of those things that we're still speculating about, but we're saying that, remember, it's the sun also has that. So other planets have magnetic fields, so it could be that we're affected by them. And really, it's it is not a gradual thing, a shift. So in other words, it doesn't, it moves completely right around rather than sort of something that moves by degrees. So it wouldn't be a progression, if you like. Okay, it would be quite sudden. So, and if it did happen, then it would obviously be catastrophic for all of us.
Would that because during a pole shift would create an EMP knocking out technology, or would it be a momentary loss in realignment of the magnetic field protecting us from the solar winds, or a combination of those things? What?
I think we'd still be protected in that way, because you know, whether it goes up, whether it goes one way or another doesn't matter. But the problem is that in its shift, that's when things that are magnetic will also want to shift with it, and that could be a whole lot of problems for us as humans, relying on magnetic fields to do stuff, which is mostly what we do with electricity.
Yep.
Oh,
Plus, we don't
interesting
even know how long
conversation.
such a thing takes either. It would be all speculation.
Yeah, we've not had one in recorded history, so
No.
yeah, it's all theoretical, but the geologic record does show it happens. Uh, so back to the moon landing deniers, I had a conversation with a very obtuse gentleman a day or two ago in a comment section here on this channel, and he was trying to use what I call the Daniel Pratt argument. And where it's talking about the rotation of the moon. Now, we know the moon rotates approximately once per 27 days, so that we always see the same face of the moon, more or less, as it orbits around the Earth. So he figured out that pretty much equates to about 10 miles an hour. And he was talking about if you were standing on a treadmill running at 10 miles an hour and you jumped, you know, you'd be in a different place on that treadmill when you land. So he expects that to happen with the astronauts jumping on the moon. Now, I could spot the flaw in that argument very easily, and I'm not an engineer or a physicist, but I think I would like to hear what the engineer and the physicist has to say about that particular experiment.
I'll let Mike do that. So who's this Daniel Pratt anyways? Is he a scholar of some sort?
No, he's a flat earther, and he made a very similar argument about if I jumped on the Earth rotating at 1,000 miles an hour, then when I landed, I would be slightly further west than I am when I started.
Oh,
yeah, that's a common misconception and a common starting from a false premise that that motion is somehow happening if you leave the ground. The motion is going on and you suddenly stop moving. But can you imagine if the tangential velocity as the Earth is rotating, if you jumped up and suddenly came to a complete stop, I'm pretty much sure you would liquefy. You would liquefy and be dead. Because the forces involved would be huge. Now you're moving along with the Earth when you jump up and you jump back down, and any other claims otherwise are kind of ignorant. And not to mention the fact that you know they talk about, you know, the Earth rotating, and if it's really going that fast, 1,049 miles an hour at the equator, then the winds would just would kill everybody. But you know, then what they don't understand is then fluid dynamics comes into play, because then there's this thing called a boundary layer of no matter how fast a fluid is traveling over a surface, there is always a boundary layer, however small it may be, at that surface where there is no motion. So on a planetary scale, it's actually called a planetary boundary layer, but it's the same thing. And so everything that's on the surface of the Earth is moving with the Earth. So if you jump up, you don't suddenly stop moving, because that literally would kill you. It's a ridiculous notion, and it's based on a false premise. And
well, if you get yourself in a flatbed truck and jump up and down while it's going 100 kilometers an hour, you'll still fall in the same place where you started from.
Yes. I don't think you can
So
jump
Absolutely.
high
that
enough.
should be evidence enough.
Yeah, it should be, but it usually isn't. Because the other thing is the Daniel Pratts of the world just don't test these things themselves. They just sit wherever it is that they sit, make their videos, and assume that now I have made a claim, so you must prove me wrong. And they haven't actually provided any evidence for what they're saying. So there's actually nothing to prove wrong.
Yeah, one of my favorite videos that demonstrates the conservation of momentum in this aspect is the one where the vehicle is pulling a trailer that has a trampoline that people are jumping on while the vehicle is moving, and
Yeah, I
they
love that.
always land on the trampoline in the same spot that they took off from.
Yeah.
It's a really cool video.
Yeah. Why isn't that sufficient evidence?
You would think.
Because it disputes their argument.
Mm.
But this is why in science we don't really talk about RPMs when we talk about planetary speeds of rotation. We talk about degrees per hour rotations per day.
Yeah.
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 It's actually pretty slow.
Yeah, 1,000 miles an hour or even 10 miles an hour for the moon's rotation sounds really fast, but when you think about the scale and the size of a planet or a moon, it's pretty damn slow.
Yeah,
Well, it takes all day.
Yeah, that's the point. It's scale. They don't understand scale. The globe deniers either don't understand it or ignore it completely. But it makes a huge difference when you're talking about the velocities and forces and how things turn and rotate and what you can and can't feel.
Yeah.
It makes a huge difference, and they just don't seem to understand that part.
I
grasp it.
Yeah. Look, I think just looking at this ball again, I think what's happening is they think that this ball is going around like this with an angular velocity of 1,000 miles per hour. Well, if you did that, that would be pretty fast for this. But in fact, you would have to stand here and watch this thing take all day, 24 hours, for this point here to come back again on this ball. Now, I reckon you'd be pretty bored to watching this spot over here for 24 hours.
Yeah, that'd be about akin to watching paint dry or grass grow.
Something like that, yeah.
It would be like sitting on the edge of a merry-go-round and get somebody to push you around once over the span of a 24-hour day. I don't think you'd be very entertained.
Yeah. Not very exciting.
Well, actually, speaking of grass grow, you might find this interesting. I've got my background is in chemistry. I started as a chemist before I went into physics, and I actually produced a concoction for tomato plants, and it takes 27 days only to get from the plant to grow from a small plant to get tomatoes.
Cool.
Wow. That's quick.
Yeah,
Where do I get some of that?
Yeah, it is quite an amazing bit of concoction with the electrolytes and stuff that's used in it. So that's rather interesting. You can grow tomatoes really fast if you want to.
That could be of incredible use for the Mars missions.
Yeah, well, actually, my actual interest in I've been asked to look at the water area part of the moon mission. So one of the things that everyone's trying to head to, and we certainly were as well, and that's to head to the south pole of the moon, because I don't know if you know this, but it doesn't get light, so it is always in the dark. So this particular area in the moon, we suspect, in fact, we know from the first Chandrayaan mission that went to the moon that in fact there's water there. So there are water molecules on the moon. The point is that so now the race is to get to actually establish a station on the moon in that area to be able to take advantage of water that's there, because the water allows you to have the fuel to come back, if you like. So you've got the oxygen and the hydrogen. The big problem is how do you store it? It's easy to make, it's easy to split the oxygen and the hydrogen, but then how do you store it? How do you make this a continuous amount of fuel? And of course, when we're talking about rockets, an enormous amount of energy is required. Not quite as much as you need in the moon, of course. You don't need that much energy. You need at least a sixth of it anyway, the energy on the moon to get going. But it's still quite a lot of energy packed into one spot. So how do you get the water to separate into the fuel and the oxidizer, and then combine with sufficient of that to be able to mount a launch from the moon's surface?
Interesting. So you would have to like purify that water first, right? You would just
actually you'd probably want it to be salty rather than pure.
Oh, really? Oh,
Because you if you're doing electricity on the moon is for nothing. It's for free. Okay, because I don't know if you've heard about the photoelectric effect.
Yep.
So I'll just quickly explain it. I hope you don't mind having these impromptu physics lessons.
No, absolutely not.
Okay,
Not
so
every moment.
if you get a particular type of metal or a particular type of alloy, and let's say I've got a little metal plate like this, and I've got a particular wavelength, say blue, so sunlight, and the sunlight, out of the sunlight, remember I explained to you the visible light spectrum includes blue and green. If this particular photon hits this electric plate, it actually drives off an electron. It's amazing. It's an incredible discovery that we can get light to hit this plate and drive off an electron. That means that if we can do that, we can actually capture these electrons and use this as an electric source.
Yep.
So that means the sun is there all the time. As long as the sun is shining, like a photovoltaic cell, you will be able to use the sun to hit this plate and drive off sufficient electrons to be able to create electricity. Now, all you need at this point here is a capacitor, so that capacitor is going to be able to store this electricity, and then ultimately some sort of battery source. And you have it. So electricity is for free once you have the equipment up there. And then you can use the electricity to do electrolysis, which then will separate the oxygen from the hydrogen quite easily.
fun fact that is one of the specific accomplishments that Einstein got his Nobel for, the photoelectric effect.
Yes, there you go. Yeah, exactly.
A lot of people think it was relativity, and it actually wasn't.
Yeah, it was the photoelectric effect. Fantastic, amazing, absolutely life-changing thing that's happened to all of us. In fact, we'd be doomed but for this.
We on submarines. I work for a company that designs and builds submarines for the Navy, and we use that exact electrolysis to produce oxygen, to provide oxygen for onboard use. We bring water in, but we don't use seawater because all of the minerals would gum up the system after a while. So we do purify it. And today we use reverse osmosis systems for that.
Yeah. So the more pure that the water is, the more energy you need to be able to separate that. So if you do have a conducting ion in there, like sodium chloride, you would. But the trouble with seawater is it contains sulfates as well as chlorides and carbonates and all sorts of other ions, which are not desirable for the life of the equipment.
Yeah.
And when you are in space, the life of equipment is paramount to the life of the people living there.
Absolutely, and also the cost of it, $36,000 per kilogram is what it costs.
That figure still amazes me.
Yeah. Yes, exactly.
Well, we are approaching the 2-hour mark in our show, and I really don't want to abuse our guests' generosity with their time. So I think we'll check in with Taddy, see if there's any final questions or comments from the live chat that we might want to address before we give our final thoughts and sign off for the day. Taddy?
So, a couple of observations to do with the nature of water. John Rapp came up just reaffirming what has been touched upon by both the professor and Mike there, that water is actually a poor conductor when it's pure water. And Dutch Heretic added to that, saying it's the impurities in water that make it conductive, stuff like salt, etc.
Yeah, quite true. Yeah.
And the only other observation was when the professor said he wasn't too aware of who Daniel Pratt was. There was a couple of observations, one of which was Daniel Pratt is influenced by his position on the bell curve, far left, where it's flat.
And that's the truth.
And the moon has no effect on his brain.
Very true.
One first.
So, I'm sorry, Teddy, you were going to say?
No, I was just going to say that was about it from the comments there.
I appreciate it. And Mike, do you have any final thoughts on today's show?
Yeah, I think we have shown that there is not a credible argument for the fact that we didn't go to the moon, and everything is that you could possibly bring up about that is just assumption with no basis whatsoever. And it also denies the ingenuity and accomplishments of us as a race and our potential in the future.
Yep, very true. Jeff?
Yeah, pretty much as Mike said. There's absolutely no plausible reason why anyone should believe that the moon landings were fake. We did it. We know we've done it. We can prove it. They just don't want to admit it. For some reason, they just want to look backward rather than forward. So yeah, they can say what they want. I'm convinced, as well as the vast majority of the planet, we have been to the moon several times.
Yeah.
And Professor Bill?
Look, if you take out the 25 odd times that humans have actually been in space and around the moon in orbit, if you even take that logic out of the equation, the slam dunk is the retroreflectors we are using right now. That is absolute proof that the landings happened.
Yep, and that's pretty much what I was going to say. The space is real. We currently are orbiting the Earth in the International Space Station. We have already landed humans on the moon, and we will again. And conspiracy theorists just need to get over it. And for everybody in the live chat, we will be back on December 1st. We do not know who we will have yet or what the topic will be. We have a specific goal in mind for that. But in case that particular guest doesn't commit to the show for his schedule, then we have an alternative guests and topics already picked out. So join us on December 1st at 11 a.m. GMT once again, where we will have another science academic-based discussion about some conspiracy claim. I'm sure it will be fun, it will be entertaining, and it will be informative. With that, Teddy, go ahead and take us out.
Thank you.
Good night, everyone.